Come on, come on. I see no changes. Wake up in the morning and I ask myself.
Remember this, memorize it, or get a tattoo of it on your arm, whatever works. But density equals mass divided by volume. What does that mean? What is mass?
Weight.
Okay, that's what they said last hour too. How is weight and mass different from one another?
Weight is by gravitational pull,
Good.
and mass is just how much stuff.
Yeah, excellent. If you didn't hear what she said weight is based off your gravitational pull of the object you're on. So if I go stand on a meteor in outer space, I'm going to weigh less than when I stand on the Earth. Whereas if I go stand on the sun, I'm going to weigh a lot more when I stand on the sun than if I stand on the Earth. I'm standing on the sun, I'm probably not doing so well, but you get the point. My mass would not change in any of those situations. I might be vaporized if I stand on the sun, but my mass would still be all the stuff that makes up me. So weight changes, mass does not. Tell you, everyone wants this monkey stand. All right, so keep that in mind. How do we find out how much mass something has? What do we have to put it on? That's volume. That's
A scale.
Yeah, a scale of some sort. So most likely on Monday you'll be using an electronic balance. If I have to, I'll pull out the triple balance beams. I'm not real wild about those things, but some way, somehow, you kind of use a scale to find out mass. And mass is in this class in grams. G. Volume is what? Okay, and that would be for a liquid. And what would it be for a solid?
Milliliters.
Remember the unit for volume for a solid? Centimeters cubed. Okay. So what is volume first before we start talking about the units of it? If your cousin comes up to you who is 7 years old and they're like, what is volume? Can you tell me what volume is? What would you say to them?
Sound on the TV.
What's that? What did you say?
Sound on the TV.
Huh? Anyone else have ideas of what volume is?
How much space is inside of something?
Yeah, how much space something can hold or takes up.
That's the answer I was looking for.
So this box has volume, and I can only fit so much stuff in this box, right? And if I were to pour a liquid in here, we'd measure it in milliliters. If I were to put solids in here, we'd measure it by centimeters cubed. What is the formula for volume?
Length times width times height.
Good. Length times width times height. Okay, so length, width, and height. All right, so density simply is saying how much stuff being mass, can I fit into a certain amount of space being volume. So if I want to make this box super dense, what could I put in it to make it dense?
Lead.
What'd you say?
Lead.
Lead. Lead would be a great thing to put in here and make it really, really dense. What if I didn't want it dense? What would I put in here? Feathers, yeah, feathers, definitely. So you can kind of manipulate the density of objects if you're able to decide what you put into it. Okay, so different objects have different densities. Now, the units for density are what?
Milligrams.
Not milligrams.
Grams.
Grams per
Centimeter.
centimeter squared. Cubed. Right? So just kind of look at what we got here. We have grams over centimeters cubed. It also could be grams over milliliters, but we usually do grams per centimeters cubed because we deal with solids a lot with density. Okay, so a gram per centimeter cubed, what you're kind of talking about for volume, and I should back up. If I'm talking about a centimeter cubed, I just want you guys to kind of visualize what that is. A centimeter cubed is about the size of that. Okay, so keep that in mind. It's a small increment, and it's also known as a cc. So if any of you are interested in being nurses or watch shows that deal with medicine or something, you probably hear doctors showing, get this person 6 cc's of morphine or whatever. They're talking about this, a cubic centimeter, and so they'd fill their shot or their needle up with that much liquid of whatever it is the doctor prescribed. Okay, and that's what a cc is. Now, I stole this pillow from our bed, and I want to find out the volume of this pillow. And we're going to, for purposes today, pretend it's a perfect cube. Okay, it's obviously not, it's rounded and all that good stuff. But for today, we're going to pretend it's a perfect cube. If I wanted to find the volume of this, what would I do?
Measure it.
Measure it, okay. And what measurements would I want to get? Length, okay. And we'll say the length of this guy is about 85. What else would I want? Width. Okay. The width of this guy is about 41. Now again, these are all just kind of estimates. It's not perfect. And what else would I want? Height. And so the height of this guy is about 19 centimeters. Does that tell me the volume?
No.
Okay, what do I have to do?
North multiply.
Okay, good. 85 times 41 times 19. Wow. Big number. Volume equals 66,215. And that's centimeters cubed. That means if I were to take a cubic centimeter or a cc and I turn it into a Lego, I would need 66,215 little Lego pieces to build this pillow. Okay, that's what that's saying.
We should do that.
That would be a fun project, although I'm not a big fan of Legos. I was just very frustrated with them as a kid. Never turn out like the picture said on the box, so don't get me started. That's volume. Now, I went to my scale at home and I weighed this and I got a mass and I rounded it. It was a little bit less than 1,000 grams. I thought, well, let's just keep it easy for math's sake, and it's about 1,000 grams to this mass. Right? So I know the mass, I know the volume. Can I calculate the density of this pillow?
Yeah.
Okay, what do I have to do?
Divide.
Okay, so I get 1,000 divided by 66,215 centimeters cubed. And I get my
Something or other.
handy dandy calculator. Did you just tell me an answer? I'm running out of space, so this quarters are right nuts. The answer is 0.015. And that is in grams per centimeter cubed. Now I'm going to kind of circle this. So that is the density of this pillow. Does that number make sense? Like, does that seem like it would fit that a pillow would have that low of a density?
Yeah.
No.
Yeah, it kind of does. I mean, a pillow is mainly made up of fluff and air and that kind of stuff, so it wouldn't be very dense. Now, if this pillow is made of lead, then it would have a much different number here. So that seems to kind of make sense. Now, we're going to kind of do something weird to this pillow. We're going to try to shrink it to decrease its volume. So, stick it in the magical garbage bag. Must be airtight. And okay, so this is my new pillow. And we want to get some new measurements. Now, how would I calculate the volume of this?
Oh, no.
Length times width times height. Now, again, we're assuming it's a square, so, not exactly perfect. So let's do some more measurements. My new and improved length is about 72 centimeters. My new and improved width is, depends on what part you measure from, is about 35. And my new and improved height, about 4.5. Now, does that give me a volume? All these numbers?
No.
No. I have to do what with it?
Wait.
Multiply, right? Actually, someone said something really interesting I want to ask about. All right. My new volume is 11,340 centimeters cubed. So how many Legos would I need to make this pillow?
11,040.
Exactly. if I had a cubic centimeter Lego, I would need 11,340 of them to make this pillow. Question for you: has this pillow lost mass?
No.
Okay, now that's kind of a trick question. What has it lost?
No.
What? Someone said it.
Air?
Air, yeah. Now, does air have mass?
No. A little.
Have you ever done the old classic second grade experiment where you take an empty balloon, put it on a scale, and then blow the balloon up, put it back on the scale, and you notice it gains weight? You done that or no? Am I just the only crazy one that's done that experiment? Okay. So if you do that, it does gain a little bit of weight. Does air have a lot of mass?
No.
No. And so the amount of mass this pillow has lost is probably negligible. If anything, maybe a gram or 2. So my mass might be, instead of 1,000 grams, we'll say it was worth 2 grams of air was lost. What's 1,000 minus 2? 998. So that's my new mass of this pillow. My new volume is what? That. And now I can calculate the new and improved density, which would be 998 divided by 11340, which gives me 0.08. Surplus because boards get really messy. So I have one density here of Mr. Shrunk pillow and one density here of a normal pillow. Which is more dense?
That one.
Yeah, right? This is a bigger number than this one, right? I want to see that. Okay, so I just increased the density. How did I do that?
Right, squishing everything up.
Yeah, I decreased the
There.
okay,
Volume.
volume. Yeah, use those science words. I love when you guys use science words. Yeah, we decreased the volume, okay? And that made the density go up. All right? Now, here's what's really cool about this whole experiment. When I let go of this, my pillow should grow back, or else my wife's going to kill me. Back to normal. We go with the pillow. Question, or actually cool little thing you can do with this, and you can do it at home if you want to, is take a vacuum and a garbage bag. If you want to make your pillows or your cushions on your couch smell really good when it's sucking the air back in, take one of those potpourri balls and put it over the hole where the air is coming through, and it pulls all that potpourri or whatever smell it is you want to into the pillow or cushion or whatever, and it smells good for weeks. So try it at home. Your parents will thank you. Now, what could we do with that would be very, very evil to say a college roommate that just played a prank on you? Fish, dog doo-doo, anything that stinks, put it in front of the hole as it sucks the air, and their pillow now will smell like fish, dog doo-doo, or whatever it is you chose for them. So then they go lay down at night, would not want to be them.